some ground rules here. So for tonight, I'm a weirdo. I love a good discussion. I love a good debate. I love differences. Just argue the point, not the person. Nice rule. That's a good way to keep it respectful for everyone. And the other thing I love to say is soapboxes are for soap. So just what I mean by that, make a comment, make a point that you want to share with the group, but don't make it a big speech that lasts for 20 minutes. And I'll try to not do the same. Okay, sweet. So my goal here is I'm not here to convert anyone to anything. We all have our own different beliefs. All I'm going to do is share as best as I can. I'm a little anxious about this, but how AI actually works in English. So you can have an understanding, and I totally respect and understand everyone will come to their own conclusions, and I'm totally fine and comfortable with all of that. So like, who is this guy anyways? And I see a lot of new faces or people who maybe not know me completely. So I am the executive director of the Southeast Tech Hub. I didn't create the Tech Hub, that was created by the community. I just ended up being here and filled in a gap that they needed. But I co-founded a software company in 2007 called IDS. It's trucking software, logistics and final mile software. So we're in Australia, United States, and Canada. And I just completed last spring and summer, MIT's Innovation and Acceleration Program. Little neat story about that. The reason why I decided to go there is Dr. Eric Grimson, Chancellor of MIT, born and raised from here, and he came out on his own accord and to talk to the community about his path and how he moved forward. And in that, he just inspired me to go back. So neat little connection there for the community. What is the Southeast Tech Hub? So essentially there's two parts of it. There's a core part, which was economic development in technology. But when I came in here to first start off, we didn't even have computer science at any level of education, I think, except for St. Mary's, which has a great program. So we knew that we had to do a lot of community development. We have computer science now at the comp, and then Tanya here and Ryan Gustafson have created the first, if you take the Trans-Canada Highway right down to the US border, Alberta to Manitoba, the first computer science program that exists in our region. And I think that's really important because StatsCan says 60% of all rural youth in Canada leave our rural communities to get a job in technology. So let's try to keep them here, right? So community development and economic development. The economic development, you might have heard about the graphite project, the hydrogen project. I mean, those are big, glorious projects, but there's a whole bunch of other little things we're doing as well. That's for another day. So let's put AI in context. So innovation, what the heck is innovation? This is my own personal definition. It's something I've thought about for a while. It's the disruption of a process to make something better. Notice I never said technology, right? It could be just a process in work, process at home, anything. It's just, you're going to do something and you're going to do it differently, better. We hope to make it better. I also like to use the word disruption because to me, this is really what innovation is. I think this is where maybe a lot of us are here tonight because they're feeling disrupted by AI, right? So in acknowledging that, I hope to provide you some information about it. Another piece is, I don't know about you guys, I feel super over-innovated. 1970s, we had a black and white TV, we had bunny ears, that's it, right? And then we got a color TV, then we got cable, then we got an Apple IIe computer, and then we got and that was over like 20 years, and suddenly it was internet, cell phone, electric cars, AI. And you can actually see this in a period of time. You know, you've got your water power, you got your steam power, you can see this timeline, and suddenly it's just getting squished up. There has never been a time in human history where we've had so much disruption in such a short period of time. So I'm validating the emotions that some people do have about like, whoa, can we just slow down for a sec? So you're very right. The other part is the hype cycle. So a lot of people will, you can think of any kind of technology. where someone will say, hey, I got this new technology, heard about this new technology, it's going to completely change the world, and then suddenly disappears. 8-track is a good, I see a lot of people similar age to me, remember the 8-track? So 8-track, everyone's super excited, it's going to take over the world, it falls down, 8-track fell off the cliff, right? But a lot of technology will slowly burn along here. A good one is like these TVs. 1990s, they're coming up here, 2000, they start falling off, they're like $10,000 here, and then by now, slowly over time, no one has CRTVs anymore. They have flat screen TVs. So I like to always show that because there's a lot of hype out there with technology, and just remember that. You might see it's going to fall off a cliff, but it doesn't mean it's all going to always disappear. AI is very clear on this. There's a lot of hype going on right now. So if you just think about this graph as you hear about AI, you can kind of put it in your mind. The other thing is all inventions have good and bad, right? Alfred Nobel is a great example. He created dynamite. And everyone thought he died. It's one of those famous stories where they put out all these news releases saying he had died, and he hadn't died. And he was reading the obituaries. And one of the obituaries labeled him as the merchant of death. And he's like, that's how people are going to remember me because I made dynamite. But you think about all the roads, our mine, how many things wouldn't exist or at that level without dynamite, right? So that's why he took his entire savings, his entire wealth, and created the Nobel Prize. It's not just the Nobel Peace Prize, it's also all these different science prizes. So just to acknowledge that innovation isn't always good, isn't always bad, it can be both. I think that's really clear with AI as well. Okay, big picture on AI before we dig too deep into it. First off, AI might seem like it's a new thing. It's not new. One of my personal heroes, Alan Turing, the legend, the urban myth about the Apple symbol on a computer, like the original one, has a bite in it. So he poisoned an apple and bit it to commit suicide. That's a whole different story. And the urban myth is that's where the Apple symbol comes from, because he's the guy who created the first digital computer. And it was code breaking in the Second World War. A good Brit, shall we say. But in all of that, he started to think about if computers can do mathematical equations really quickly, can it logic? Can a computer reason? Can it help us understand things? So he was one of the first people to bring up the term of machine learning. And that was in 1950. So that was 70 years ago. And a little bit more about the history. Again, I'm just trying to show you that AI didn't just suddenly show up yesterday. It's been worked on for a while. So 1940s, 1950s, and you can see all these different little things happening along. A little thing, Arthur C. Clarke and Steve Kubrick. You would know Steve Kubrick. Space Odyssey 2001, the movie. He's a very famous author, but they both started to coin the phrases of machine learning way back in the 1960s. So again, I got so much material, so if I'm going too fast, let me know. But just again, I'm trying to show you, it's been around for a while. The term artificial intelligence, which I personally don't like, I'll get to that in a minute, but that was first coined in 1956 with a paper by the famous Rand Corporation. I'm sure we all know about them. We'll leave it at that. Okay, that was the history. You'll see why I'm going so fast in a minute. There are three basic types of AI. There's narrow, where AI can only do one thing. That's it. It can only have one type of intelligence. Good example is you use Google Maps to tell you how to get here to Regina. Though if you need Google Maps to do that, I think you're in a bit of trouble, but you know, that is AI figuring out the route. Then you got general AI. That's you, me, We have more than one intelligence. We can do multiple tasks. We're capable to do multiple things. So this is the famed AGI that you might hear, general AI. The thing is, we might not have learned the skills how to code, but we have it in us. So that if we can code, when AI can actually code, because it can't right now, I'll get into that in a minute. When it can actually code, it's going to surpass us and become super intelligent AI. So that's why you hear a lot of people rightfully concerned about AGI, because the minute that happens, we're here. And what I like to say to government officials is that's why we need to start making laws now about controlling this, because this is going to happen. And the minute this happens, that's going to happen and it's going to be too late. So we need to create government policies and understanding around that. So where are we right now? The cool thing is AGI, we're way off. There's a lot of hype on that. I'm going to break that down for you so you can understand it better. But we are just at narrow AI. Google Maps. I'll get into all the different versions of it. But things that you have seen, natural language, even autonomous vehicles, that's narrow AI. It's very complex narrow AI. But the only thing it's doing is driving a car. That's it. It's not doing anything else. Pretty complex. Some examples of AI that you're already using that you might not even know it. Social media, huge. Your For You page, AI, Zuckerberg talks about this all the time, has figured out what motivates you to use that social media page. And it's saying, I know you like these things, I'm going to feed you. On the other side of that, people are using AI to make posts to make you engaged. If you give me enough money, I can make all of you vote to have Trudeau come back. Give me enough money, I could do it. So just think of that when you're using social media. You hear the term bot? That's a real thing. So just be careful with that one. Google search originally was just a logarithm, which we'll get into in a minute. But now it's using AI. It's learning where you live, and helping make your searches get to what you want a little bit faster. However, Google's getting in a little bit of trouble right now because the industry is thinking that they are using their AI to send you to places that will make them more money instead of giving you the information that you need. And also, I don't know if you notice now, when you Google something, you get this. Okay? And the funny thing about that one is someone was like, what was it? How to eat a rock. And it will tell you how to eat a rock. Because it's just not as smart as everyone thinks it does. You probably heard of that one. Another example, Google, Siri, Alexa, that's AI, and it's just using it's learned to understand what you're saying, and it will turn it into words, and then another AI will put those words into a search, because there's actually two AIs going on there. Android Auto, I use that all the time when I'm driving. I don't know if you guys use that. Voice to text, again, Android Auto. That saved me a lot of tickets. Google Maps, Waze Map. So how many of you here use any of those things and are now realizing you're actually using AI? Yeah, cool. Big one, OpenAI, ChatGPT. I personally use that all the time. I'm dyslexic. Ask my son, I can't write right? So I'll use that to make myself sound smart. It's wonderful, great thing to use. All I do is I type an email out, copy and paste it, and say rewrite for grammar and spelling, and it fixes it for me. The other thing I love to do is just do a long thought process. Like I have to write an MOU with a university. I'll just write a big, long thought process about everything I'm thinking about, and then we'll logic back and forth, and then I'll say, hey, go create an MOU for me, and it will do that. All of that is language understanding. It's not this like super intelligent being behind there really giving me good feedback. It's really just going off and doing Google searches really quickly and pulling up information. That's why you get some weird results sometimes. Okay. The other one is people think that that ChatGPT can actually write code. It can't. Trust me. I ran a software company for 20 years. Programmers are so lazy. There's a thing called Stack Overflow and other things like that where you can put the code that you've written to do certain things, and then when you need, you can go there and say, I need to do the same thing, and you just highlight it all, Control C, go into your software program, Control V, and you've written code, right? Then the human has to figure out how it works. So when you ask ChatGPT to code for you, it's doing that same thing. It's just automating that process. It's not actually coming up with unique code. And that's why usually AI made software programs break, because there's no human in there. And I like to also let people know that, because people are worried, rightfully so, that we're at the Terminator point where AI is actually writing code, and it's not. It's just copy and pasting. Okay, so now I'm going to try to do something I've never done before. So I'll slow down. I'm going to ask you guys for feedback to make sure I'm getting this across to you. I'm going to try to explain AI in English. I'll do my best in how it actually works. A moment ago, I said, I don't like the term artificial intelligence. I prefer the term automated intelligence. A good example is driving a car. AI is automating the intelligence to drive the car. I think it's just more realistic, because it also helps us understand how it will affect society and ourselves. It's going to automate things. Just a quick little bit there. So now let's start breaking these down. I always mispronounce this word. I'm sorry. Algorithm is a recipe. It's like you have a recipe book and you're saying, I need to make a cake. And it says, first, get these ingredients. Second, get the eggs, crack it, and work your all way down. That's all that algorithms or codes are. So for example, you're going to make a recipe that says, find the cat in this picture, okay? And you're going to say, first thing, look for something that is furry. Next thing, look for something that has a tail, things like that, right? So it's going to go through that. And if you actually, and when you look at code, the code that we write now, it's very much in English. You can actually pretty much understand it if you've never looked at code before. Right, James? Yes, cool. So that is where we're going to start. We're going to give it instructions, algorithms. You're going to make it do these. Then we're going to say, we want that AI to automate the thinking process. And so it needs to look at a lot of examples, just like us when we were kids doing flashcards, right? Here's a flashcard, here's another flashcard. And slowly, as you work your way through these flashcards, you start to learn something. We're going to do the same thing with those instructions. Because you can think, hey, just look at for a furry animal. It's going to be like, what's a furry animal? So to do that, we need a whole bunch of data. So this is where you're hearing a lot of people getting rightfully concerned about copyright, because people want to say, I'm going to build a large language model. In other words, software that can write English. I need a whole bunch of data that shows English being written, right? Books. So it goes on the internet, finds a whole bunch of books. So it's grabbing that data. So people are rightfully concerned, saying, hey, you're making money off my book. That's against copyright laws. I should have something to go there. My personal opinion is, I'm not sure where that goes. I'm just going to let the courts work it all out, and the policymakers, and us asking the policymakers how to work it out. So we're going to have a whole bunch of training data. We're going to have 10,000 photos of cats and dogs labeled cat and dog. So it'll be on the back. It'll be like a flashcard. There'll be a picture of a cat. And on the back will say cat and dog. And literally, that's what we're going to do to the computer. We're going to say like this, and like this, and like this, and like this. Okay? Am I losing you guys? Simple enough? Okay, good. Awesome. And as we show a picture, say it's a cat, and it says dog, and you would just simply say no. And just like a kid doing flashcards, and you show up another one. Cat. Says cat, yes. And when you start, it's going to make a lot of mistakes. But eventually, it will start the code. It will update its recipe book saying, okay, so cats have pointy tails. Okay, dogs don't. Cats are smaller. Okay, look for something smaller. Things like that. It will start updating itself. I just kind of covered that bit. So what you're doing is you're just like learning a guitar. You're teaching the software program like you and I would learn how to do a guitar. Repetitiveness, guessing, and checking. Now I didn't put a slide in here. How many people have done statistics? No? Okay, yeah, of course you have. Okay. So you can do like averages. Like you got a whole bunch of numbers or a whole bunch of things, and you can say, or a whole bunch of people, what's the average of the age of the number of people here, right? I won't say anything. And so that's what you're doing with a computer. You're going to say, in this sample, the average age is 19, because really that's probably how old we all are, right? So the first thing it's going to do is, in its math, say 19. And you're going to say, no, it's a little higher. And it will say, okay, update it. And it's learning the averages. Am I communicating this well? Getting me? So that's the math behind it all. So how do we know it's working? When I did AI design at MIT, we never would create a document. We'd never create a project where we would say it's 100% right. We're not asking for 100% right, because if we're automating human intelligence, well, you can ask my ex-wife, I'm not always right? So, sorry, Britt. So we're not saying that when we go to double check it, we're not wanting a perfect. We want a certain threshold, 80%, 90%. It depends on what we're doing. If we're teaching AI how to drive, we want it 99% of the time right. If we're teaching it some medical process, again, 99.999% right. If we're just teaching it how to write something, 70% is fine, right? So it's just the threshold of the design that we want. So that's how we can decide if we feel it's right. Okay. Still, you guys following along right? Okay. Oh, we could hear all of you, Doug. It's fine. No, we've already done that one. Okay. So that's in essence how AI works. You got a whole bunch of data, you create a recipe, and then you say yes or no, and then once you feel like it's getting it 90% right, you're like, okay, I have a program. So that's how AI works. But I'm going to pull us back for a sec, because there's a whole bunch of hype about energy use with AI. So I just want to break it down for you to understand where we're really going in some of this hype. And also there's a lot of concerns about AI making mistakes, creating what are called hallucinations. And I'd argue those hallucinations is actually very intelligent. And so to explain that to you, I just want us to stop and think about what is intelligence. We constantly think of intelligence as being, I'm always factually right, but that's not life, right? The best way to describe intelligence is, I'm going to throw you in a new situation. You've never been there before, been in that situation before. How quickly can you figure out how to exist in that new situation, accomplish something? To me, that's more about intelligence. It's not how much you know, it's how well you can adapt. So how would you learn something in a new situation? you're going to probably start looking for patterns. Maybe some kind of pattern that's similar to what you already know. Say I'm going to put you in a foreign country you've never been to. Everyone speaks a completely different language. The buildings are all completely different, but you can see a pattern that you recognize as a street. It might not look like a normal street to you, but you can see that pattern as a street. And so now you're going to say, okay, I need to get back to my hotel. So you start walking down the street. Then you're going to start looking for patterns like, I know in Estevan, I see street signs. I don't see any street signs. Where can they be? But you kind of know what they look like. It might be in a different language, and then you look at the ground and, oh, maybe they're down at the ground, or maybe they're on a building. Again, I'm looking for patterns, and I'm learning from that, and then I remember that. That really is what the core of intelligence is. And this is something that bothers me a lot because I run into a lot of people, I think we all do, who, because they know a lot of things, are arrogant because they think they're intelligent, where someone, and this is an argument I always put up there when I'm talking about rural innovation, is someone working in the oil and gas field, a farmer working in the farm, solving a problem he's never been into. He might not have had a formal education and know all these facts about the world, but he's still intelligent, or she's still intelligent because they can quickly solve that problem. And I think that's really important that we talk about things like that, especially in Estevan, and we're talking to others outside. So yeah, and so another part about intelligence is being able to be flexible. So you'll notice people who you think can come up with really new, neat ideas, who are innovative, who can solve problems really quick. They're willing to think out of the box. They're willing to be flexible with, say, their values at that moment in time just to solve that problem. Like how to explain it? You're in a different country and they have a different way of, like they don't pray, say, before dinner, but they do something different. We're going to be more flexible with that just to help solve our problem of being able to enjoy dinner with them. Things like that. Did that get across right? Yeah, you get it? Okay, cool. So try something new. You'll notice that pattern in people. But here's the biggest thing that a lot of people don't really understand when they talk about automated or artificial intelligence. Intelligence also includes maybe. So again, at my MIT course, I found it interesting to talk to all these really smart people who want to use AI to help them find solid facts. But intelligence isn't about solid facts. Intelligence is in the gray. Intelligence, as we know in our lives, when we have a problem that we need to understand or work through, we'll take a guess as best as we can. It's a maybe. And 99% of the time, we'll look back and say it wasn't right, but we had to make a guess. And I'm sure you guys have all made decisions where you had to live in the gray, whether it's work, family, relationships. It's gray. So hold on to that for a second. Intelligence lives in the gray, or maybe in the maybe. So just reiterate, just before I move on to the next piece. Intelligence is about solving something you've never seen before, looking for patterns, being comfortable with being in the maybe, being in the gray, or try something new. Okay? But here's the biggest problem that we have with AI right now that a lot of people are missing out on. Even the guys who are talking, like Sam Altman, who owns ChatGPT, they'll talk about how we're on the cusp of it, but there's a big problem that they don't really communicate well, or they're ignoring. And that is, right now, we are using what are called classical computers. They have bits, okay? A bit is just a light switch. It could be on, it could be off. It could be 0, it could be 1, it could be black, it could be white, okay? So to make the letter A, I have to have 8 switches to make this letter A in my current computer. 8 switches. That is the letter A in binary. Like in machine code language, at the very core, you have 8 switches, just to make that one letter. So fun fact, one page of text, 16,000 switches have to be on or off in some kind of pattern. Because you can't, it's either black or white, on or off. I think you can start feeling where I'm going. So how do computers make gray? How do computers do maybe? Classic computers. So you're trying to make artificial automated intelligence exist, but we just talked about intelligence. Intelligence needs to be gray. So how do we do gray? This is, computers just have the 3 primary colors, and it will say this pixel is going to be a mix of red, green, and blue. And I'm going to say 1 red, 2 green, 0 blue, something like that. But to make gray, the red has to be, say, number 1, green has to be number 1, blue has to be number 1. So what I mean is, like, it has to have quantity of each. So think of it as a paint bucket. Red, green, blue, 1 drop of each, boom, gray. That's how it does it. But here's a problem with it. You have to store the mathematical formula just to make gray as 8, 8, 8. So 24 different bits, okay, total. But 1 pixel has to store 16 million colors. So all I'm trying to convey to you is that's a lot of light switches you got to have on or off. And so you can see why when people are talking about artificial intelligence, we need these massive and massive computers. It's like we're going back to the 1960s where this little computer, well, it wouldn't even exist, but a computer back in the day would take over a whole entire building. It's because we're hacking it. We're hacking artificial intelligence, something that's gray, to be black and white. So again, think gray, think maybe. Okay, I'm going to try something. I think I can do this. Quantum computing. I'll start off by simply saying when I started learning about quantum computing, I was sweating buckets. I'm like, oh God, this is going to be painful. I'm going to be in 2 places at the same time in different dimensions, because that's what I was told. They're just saying that stuff just to make themselves sound smarter. It's actually not that complicated. This is a qubit. So a bit, they just put qubit for quantum. This is what a classical qubit looks like. So on, off, 0, 1, black, white, okay? So what's happening in here in the classical qubit, I know we have some electricians in the room, they have an electron just is spinning. Like, when you look at a molecular structure of an electron, it's spinning around something, okay? So just like how the Earth's spinning around the sun. So it's spinning around, but say we can make that spin slightly change, and they can do this with magnet. Instead of spinning around perfect, we're going to make it spin around down here, okay? Well, now I can store the number 0.25 because I'm a quarter of the way from 1. I just did that with 1 bit. I didn't do that with 8 bits. I didn't do that with 24 bits. I did it with 1 bit. I can make it spin here, 50%, 50. I can make it represent like pi, which just goes on forever and ever, right? So I can store these massive numbers using 1 switch now. So why is that? Oh, actually, before I get into the important, the funny thing is, you'll hear people say, quantum computers won't work because when we look at it, it changes. And they're just trying to sound cool. Oh, you look, how does it know it looking at? Oh, it's going to switch. What they're meaning is you can't see it. So you got to shine something on it. So like a light to see where this electron is actually spinning, because you now have to read what you just wrote. And that the light, just like me shining light in your eyes, make you close your eyes, it will alter this. It will suddenly spin differently. So that's what they mean. So quantum computing means stuck in this spot where when they go to read it, it's moved. They can't figure it out. So just about 2-3 months ago, Nature published a research paper by Microsoft on research that they completed a year ago. And they have solved the problem of the qubit that you can't see it properly without changing it. And what they did is superconductor, just think copper wire, but it's really cold, okay? And at either end of the copper wire, and I'm sure some of the electricians will know this, if you put a current through that, you'll get a bit of a electron EMF, like a field going on there, like a magnet on either sides, right? Okay, so if I just keep electricity going through here and there's no field on either side, it's flat, okay, the thing is not on. When I power it up, just look at it this way. Instead of using that globe, I can power it up so that when I look at it, say on a graph, an oscillator, it looks like this. And how big or tall it is how close is it to zero? Sorry, zero's down here and one's up to here. Okay, so I can hold that information. If it's halfway to there, then it's 50%. I've stored the number 0.50, okay? The reason why I did this is they realized they can hold a clone copy on this using this one wire, because you have an electron EMF on either side when you put electricity through it. How many people have I lost? Really? You guys are all getting it? Sweet. Okay.
How do you do negative numbers?
I guess you make it. You would have to do an absolute value and then say it's negative. So you would say 1, absolute 1, but then it's negative. So yeah, it's the best way to do it. So they now have 2 copies. So if they lose the state of where this is, they know that they have another copy over here. So this is a really neat solution, because they can now, they're saying, again, I'm aware of the hype cycle that I shared with you. They're saying that this will be in production in 2 to 3 years, because what they published just now was based on research they completed a year ago, and it's ready to go. Now, the only thing they still haven't overcome is this has to be pretty close to absolute zero, which is minus 276 degrees, pretty cold. So they still have to put it in these big vats that keep it really, really cold, okay? So it's still, you're not gonna have one of these in your house. It's gonna be in a data center, but instead of holding 24 switches, you're just gonna have 1 switch. So what does that actually mean? And this is where I'm gonna get to some of the hype to explain it, especially in our community, which is an energy city. You were hearing a lot of concerns, thoughts about power consumption, but you can also see, like, when people start talking about general intelligence, until quantum computing, until that's getting somewhere, we're just not going to be able to do it. At the same time, when those chips come into play, we're going to be doing it pretty quick. So our policymakers need to get on that and stop sitting around, right? And it's interesting because Eric, when he came out from MIT and talked about it, he gave a big spiel about how we have to have rules and regulations around AI now. So even like at his level, he's saying we need to do it. Even Mr. Elon said it. True story. But let's break this down further about power consumption. If we use classic computing, the kind of computing we have right now to power AI and all the dreams that we wish and want, in the next 3 years for North America, that's gigawatts. That's not megawatts. Just in the next 3 years, we have to produce 7 to 10 gigawatts, enough electricity to power 7 million homes. If we go further out, in the next 5 years, 20 to 30 gigawatts, roughly double Canada's residential power use at this moment in time. Yes?
One quick question. So when you talk about the gigawatts, is that just for this?
Mm-hmm.
Just to run AI, nothing else?
Mm-hmm.
So as anybody did calculations with all the chargers and all that stuff, what we're gonna have to produce?
Well, not just that one, add another one. Trump with his tariffs on aluminum and smelting and all that, and he wants to bring aluminum smelting back to the United States. What I had read, so I don't know how truthful it is as truthful as the author wrote it. They only have 4 smelters, and the amount of power, they need 3 of these boundary to just do 1 smelter. And so you now have these 2 competing. They're like, wait, Trump, you said you want AI, but you want aluminum. You can't have both because of this. Yeah, that's a whole nother. Yeah. But just think on that one for a sec. But if we go even further out, like this is ridiculous. This is ridiculous. So when in my world right now, I'm getting a lot of people in the venture capital world seeing this as an opportunity to make a lot of money. I think in our community, we look at that and say, yeah, good luck. Yeah, no way that's going to happen. Yeah, not going to happen.
We can't build power plants that fast, even if they're coal.
Nope, yeah. So because I'm actively out, I think some of you guys know this, trying to get data centers here. But the reason why I want the data centers themselves don't make that many jobs. The jobs that they make are very high paid jobs, highly skilled. Tanya and her group can educate people in our community to run those. But where the jobs are in energy. So what I'm talking to SAS Power, CIC, SAS Party is that electricity has to be cheap, because that hype cycle, when all the hype, we're up here right now, when it crashes down here, if we don't have good, cheap, stable electricity, we're not going to handle that bottom. We're going to go way down there. And somewhere else like Newfoundland that has 2 cents a kilowatt hour electricity, or BC that has 7 cents a kilowatt hour, they're going to win it. So something that we need to think about. I kind of went off on a tangent, but here's the thing that quantum does. This is the line we were just talking about for classical computing. If the promise that Microsoft's qubit can come out in the next 2 to 3 years, the amount of energy, it will be 60%. 60% reduction. This is what the line will look like if we build all our AI's hopes and dreams and wishes. It's going to be that flat line. So again, I just met with the provincial government on Monday, and I was saying, this is what's actually going to happen. So this is where we need to be if we're going to be realistic and make sustainable jobs. But also for yourselves, when you hear people talk about, oh, there's going to be all this massive need for energy, you now can see what it actually looks like and actually what's going to happen. The other way to say it is, if you're running a for-profit business and electricity is your biggest cost, what are you going to do? Everything in your power to get that thing down. And that's what's motivating so much work on quantum computing. Okay, any questions on any of that? Did I lose anyone? Oh yeah, go for it.
One more question. So you talk about that. You talk about superconductors that mean 0.
Sorry?
Is that in the data centers that you're talking about? That you're going to have these supercomputers that mean 0?
Yeah. Like at the mine, absolute 0. Yeah, they're going to have them. They already have them. Like right now, for my software company, we're on a Microsoft system called Azure, and they already have quantum computers that we can tap into. But the qubits, there's only like 4 qubits that you can use. So so they already have these huge vats. Just look them up. They're these big brass things, about this big. The chip is still that big inside it. So that's why they're going to still need those data centers, because for the next 20 years, that cooling system is not going to get any
How
smaller.
do they achieve absolute 0?
Oh, there's a whole bunch of different ways to do it. Nitrogen, heat sinks.
Liquid nitrogen, which means
Go for it.
oil for production, right?
Sorry?
Where you get nitrogen from?
Oh yeah, there you go. Yeah.
It's got to come out of the ground. I mean, it's there, right?
Or
And refine it. You can take it out of the air, but that's a whole different process, right?
I like how you think. How can we make money on this? Because in the back, that's part of the reason
That's what you need. Lots of that. Right?
that I'm doing this is one is I think everyone deserves to know how all of this works to make their own conclusions. But the other is when you hear me going out in the world and saying I'm trying to do data centers in our community to try to create jobs, you'll now have a better understanding of where I'm coming from. And other examples like the nitrogen or how I'm turning coal to hydrogen, all these things. So yeah. Any other questions, or I'm going to move on to the big one.
Just an observation, your flat line is still an 11 to 12% annual increase, which is not actually very flat.
You're an accountant.
No,
Oh,
that's the account.
oh, that's the accountant. Still, it's not as bad as this. Thank you.
It's not exponential like that, but 11 to 12% is
Still nasty, yeah.
That's terrible.
Yeah.
It's an economic driver, a huge economic driver.
Okay, let's talk about the one that a lot of people are rightfully concerned about. And this is the main reason why I call it automated intelligence instead of artificial intelligence, is jobs. What is it going to do to jobs? And just a reminder, I'm not advocating for AI. I'm just telling you what is happening with AI. I'm not saying I'm advocating for your job loss. I'm just trying to explain this to you so you can make decisions for yourself. So in general, the latest number, I will admit, the only place I could find these numbers was WEF. Okay, so World Economic Forum. So I'm being honest with you where I got it. Okay, so they're saying 85 million jobs will be lost, but it could also take 97.
Sorry, is that worldwide or North America?
Worldwide.
By 2025, I think we're there.
Yeah, I should have updated that. But okay, this is where the most of the jobs are going to be lost because it's automating things that people do that are just data driven. So legal aid is a huge one, right? So what does a legal aid do? They go through case law, find the right case law for the lawyer for that case that they're working on. So that's something that could be automated pretty quickly. A lot of clerical jobs, a lot of management jobs. I'm sure people will be happy with that. This is percentages. So give you a feel. My capstone project for MIT was, my wife didn't like it too much because it was having AI look at all the data from a patient and help her diagnose it. And she was like, hey man, that's my job. So I didn't do it, but where will it create jobs? Oh, by the way, the content creator, that's not what you think it is. Content creator there isn't like an Instagram person. AI needs something to learn off. So if we're going to teach AI how to paint, how to make pictures, how to make videos, we need to give it data of what pictures look like, what videos look like. And we're already kind of there. In fact, we're more than there, that they've run out of data. They're asking AI to make the data to train itself on. So that's like, and I think this is so stupid. That's like, I'm going to ask Bill to write his own test that he's going to take the test on. Like it's just, it's silly. It's silly. But you'll notice there's a reoccurring theme here. There's it's about emotion, because computers still can't do that, and it's about critical thinking. That's, I think, more and more going to be super important. And like what critical thinking means is it's not being critical of everything that comes across your plate and being negative. It actually means thinking about thinking as you're thinking it. So what I mean is someone tells me something, I'm thinking about it, but as I'm thinking about it, I'm realizing I'm having an emotion. Where is this emotion coming from? Is it a bias? Is this something new? So I recognize that, and then I go and try to understand what evidence is there to back that up. Am I right? Am I wrong? So more and more, as AI automates intelligence, we're going to run across things that isn't correct. So businesses that deploy artificial intelligence are going to need a whole bunch of critical thinkers who can do that. Saying, the computer is saying that, it's saying something that I like, but is that right? And so I'm going to go double check it all. It's that cat-dog thing, right? I've shown it cats, dogs. That's a very simple version. Getcha? Okay, cool.
How about all this sensorial thing that, you know, as a human being, you see, you feel, you have all these senses. Artificial or automatic doesn't have that.
No,
So
it doesn't have EQ.
No.
It doesn't have emotional quotient. It will have intelligence quotient.
And sensorial impressions.
It can do that.
It can do that.
It can not in an emotional way, but in an intelligent way. It can, if you push on a sensor, it can feel that. So with virtual reality, augmented reality, we've already created all those sensor things. So we can just plug that into automated.
But the way it is processed, is it really the same way?
No, it doesn't have EQ, like I say.
Yeah.
It doesn't have a soul. Have you seen the movie Her?
No.
Who's seen the movie Her? Okay. Recommend seeing that. It's where a man falls in love with an AI. And it's Scarlett Johansson is the voice. And it really talks about, like, you're talking to zeros and ones and you're having emotional connection. And it's a good story for us to think about right now, is that as we create artificial things to communicate with, like instead of typing here, I'm going to talk to my computer soon. I don't want to have an emotional connection. But at the same time, who here has named their car and love their car? And as you drive, drive 2,000 kilometers and you finally get there, you're like, oh, that's a good little car, right? So it's not something completely new.
So kind of going all the way back, like, so if we hit AGI, then so you're going to have super intelligence pretty much right away. If we don't have any rules in place, like extrapolating this out, but does this not eventually put everyone out of work? Do we not just sit around doing nothing all day because we have robots and everything else? And what do we do?
Yeah, and thank you. Because a lot of people will think, like, I'll just turn this on a personal experiences, because I'm involved in AI, will think that people that are involved in AI are limitless. And there are some people out in this world right now, because all they're thinking about is money. They just want to just disrupt to make money using AI, and they don't want limits. But that's why you'll hear me, even Elon, Eric Grimson, and others say, policymakers, you need to start making policy now and think about this now and make laws now. And I think all of us need to say that. So I'm sure people have also had the opposite experience. When you say that, people think, oh, you just don't like new stuff. You're just one of those weirdos who don't like new things. That's not right. You shouldn't be saying that. Like, we need to have real laws about it. There was the debate about a year ago about, are we just going to have a welfare state where we're just collecting checks and AI is doing everything for us? I would argue, though, it doesn't have to be that way. It won't most likely be that way, because remember when internet came out, people were saying the same bloody thing. And if anything, it actually kind of made it worse, right? So yeah, go ahead, Paul.
I think when computers became first introduced, it was going to save us all this paper. I'm not sure if anybody has noticed lately, but I think we generate more paper now, don't we?
Yeah, for sure. But we do need to make rules and guidelines on it. Like, should AI have ultimately responsible for your medical care? No, I think it should be a tool. Should AI be in military equipment, manning it, automating it? No, I think it should just be a tool. At the end of the day, you're going to need to have humans involved at the top. So I don't believe Terminator is going to happen, but it's a good message to our world right now.
What I experience is a simple thing like that. When I'm kind of searching for some information, it happened to me last year when we went to Switzerland, or was it the year before? And I tried to find some answer for my questions. and all the time I got in touch with a machine.
Mm-hmm.
And I was so fed up. I wanted to talk to a human being who kind of talks to me, and not a kind of a computer. Yeah, I had it here very fast.
But you just nailed it. I think I heard you right. Now, sometimes when you think you're talking to a human,
Yeah.
you're not. The voice synthesization and the able to communicate and hold a conversation is so good now. I'm not trying to scare you, but that's.
I don't believe it.
My Alexa says goodnight to me every night. It turns off all my lights. I say, goodnight, Alexa.
You need to see her.
Oh, we'll see you in the morning. Seriously.
Yeah, but this is this one I recognize, Google or Alexa, but really someone who has kind of caps my emotions and can kind of get in tune what I'm feeling, what I'm experiencing, and that's I don't believe that AI is not.
It doesn't have that ability yet, no.
It can mimic it. It can mimic.
Yeah, but
I'll get into that.
I'm not sure whether really. I only will say, yeah, I believe you when I really have it, and I have it.
Yeah, well, I'm gonna say Google's pushing Gemini. The Gemini now has more realistic conversations, and I get emails about it all the time. I'm just like, I haven't tried it. I don't know. I don't have any interest in wanting to try it. I don't know.
We could at the end, can we come back to that conversation? Because I think that's a really good conversation because like I was just kind of hinting at, it's a tool. We need to think of it as a tool. We need it in all ways, from laws and policy and guidelines all the way down to how we do things. But here's just another thing. What will I need, like in an AI-driven world? What will I need? I might not be always using AI, but you'll notice there's things like bias detection in there, emotional intelligence, what we were talking about a second ago. I'm going to come back to bias in a second. Because AI is so good, it has a problem. Anyone wants to code? This is the kind of coding that you need to do. AI is so simple. When I was coding in my program, it was a drop-down. What logarithm would you like to choose? And you say this one, this one, this one, and you create little patterns, and then you dump a bunch of data and it goes through. If I can code, you can code this stuff. Like, this is how simple it's getting. But to create those recipes, you need a PhD, but we're getting to the point where you don't make too many new recipes, shall we say. The bad side, bias. So we're teaching AI how to do something on data. Who created all that data? We did, right? And so whatever biases we have as a society, whatever biases are within that data set, that AI is going to learn, to the point where the US Border Services had to pull one of their recognition AIs off because it was like labeling all the people who were Black were bad. Like, it was things like that. Like, that's a true story. So we got to be, that's that part where we have to recognize that bias. We can't think of like that person in my MIT course who thought AI was going to give her all the facts that are like down to the existence of the universe. And no, it's not that. It's automated. It's not coming up with actual answers to the universe. The big one this is the one that drives me the most crazy. Social media is a weapon now. It is a weapon, and mainly by AI. Anything that you see on social media, even if you agree with it, take a moment. And the one thing I'll do is I'll Google search the exact opposite, just to see what the argument is for the exact opposite. I've learned a few things. So that's all I can say. And also creates echo chambers, because it's going to it knows what makes you want to use that social media platform. So it's going to keep feeding you that. It's never going to introduce to you something new. It's to the point now where I miss an old newspaper every Sunday, because you'd read what you wanted to read, and then by Sunday afternoon you're bored and you'll start reading the sections that you didn't want to read, and you learn all these things that you never thought about. I'm actually thinking that would be a good business model, eh? Bring up old newspapers. So we talked about copyright infringement, privacy risks. I think everyone knows about what's happening in China with social scoring. That is true. It's not a conspiracy. They're not as far along as a lot of people think they are, but that is something that we all need to be aware of, and that's where we need policies. Okay. The other, sorry?
Who's going to develop the policy?
That's our job. That's our job to put the pressure on them who make the laws to make the laws.
Not working very well in the States, is it?
No, that's a whole other different story. Yeah, that's a huge story. But here's another one, hacking. Once you put AI on quantum computing, with every single password that exists right now can be broken within milliseconds. But it's okay, because we'll replace all those passwords with new passwords created by AI on quantum computing. So it's going to be interesting to see how that rolls out, because we're going to have to go, mine's better, mine's better, mine's better. It will probably mean it won't be characters that we see. It will be something that's encrypted behind the scene, something like that. Copyright one. This one, I don't know if all of you guys know this, but I was a videographer forever and a day. I made that video about Estevan and stuff like that. I don't know if you've seen that. Did the Speedway stuff. So I have this artist side to me. So as an artist, I'm half and half on this, because, so for example, I love doing astrophotography. Those are the stars, right? Or Northern Lights. I didn't just come up with that on my own. I watched somebody else who's an artist who taught me how to do it. So am I infringing his copy? Especially if I then copy what he did on my own with my own camera and then sell it? But at the same time, I don't want someone to take my actual artwork and make money off it. So I don't know. I know, Ruth, you have thoughts on this too. I don't know where this goes. It's a real interesting debate. And I know you like what you do as a film person, right? Like how you learned how to do films. Same thing. Someone taught you. So aren't we just teaching it? I don't know.
It's the difference between the technical way of doing it and the actual end product.
There's a personal touch too, right?
Yeah, exactly.
Oh yeah, there's the EQ. It's missing the emotional intelligence.
And it's that, if you look in the front of, in the front of the book, it says any copy in part or whole has to be obtained in writing from. If that's part of the copyright.
Yeah.
So it is a copyright infringement, actually.
If you take the exact paragraph and put it in, but say you read that paragraph and go, I like how his voice.
That would be the point, then where does it go? Right?
Yeah, it's a tough one.
Yeah.
Okay.
Or you have a kind of an artwork, and you can have a copyright on it, maybe, and then someone comes and just changes a couple of tweaks, and then your copyright is gone, right?
It's like a patent.
Yeah.
100%.
Because I can, a patent, if you have develop an automatic switch or a resistor that acts as a switch, and somebody takes that out and puts a timer in instead, right? They've changed the basis of the machine, but really truly it operates the same way.
So I want to now show you a company in Regina that's doing something that we can all really relate to. These guys are super, super exciting and cool. So what they're trying to do, or now they've done it, is at the grain elevators. When grain comes in, instead of having a guy who's had 8, 10, 20 years of training and experience who looks at the grain and say, it's this kind of grain, it's got this kind of mold, it's got this, they're using image processing to grade the grain. And the idea is, well, the first pain point, which isn't up here, the reason why they started doing this is they were running in as farmers themselves, where the grain elevators around them didn't have those people anymore. because none of the youth want to take the 8 years, 10 years it takes to learn how to grade grain. They just don't want to do it anymore. So they said, hey, I can solve that pain maybe with automated artificial intelligence using image recognition. So yeah, so this is a picture. Oh, you can't see it too well, but there's little things that are highlighted. They turn that into a graph, and they can start seeing what type of the grade of the grain, but they can now also hook that up to the combine. So as the combine is coming through and it's doing its thing, it will take a sample every once in a while, and it will grade that grain, and then it will overlay that on top of a map. So the farmer can see exactly where that grade of grain is coming from, or mold, or what have you. Again, I'm from BC, so if I'm saying it wrong, forgive me. It's just some more examples of what they're doing. So the big one is it's groundtruth.ag that are doing it. The other thing I'll just leave it out there. The other thing that they're doing is consistency. So if they have their software, say here at the Port of Vancouver, over at the port in China, and the grain is constantly being graded, you're going to get more consistency. There is a problem though. If they screw up once, it's going to be screwed up all the way and no one's ever going to catch it. So that's where you need that human to double check its bias. So, and the USDA is actually very excited about this as well. Yeah, I think I spent more time talking about that. We're doing okay for time. Are we? 8:30? 7:30? Okay. Any other questions, thoughts?
I have one question, G. Way back in your presentation, you showed how many jobs are gonna be lost to AI.
Yep.
Has anybody ever determined how many jobs are gonna be created by it?
Yeah, that's why they're saying there's going to be 97 million.
Oh, I've never seen that.
Yeah, sorry. So take the number as a grain of salt, but all those new jobs that I was showing you, there's different skill set, those jobs are going to be replaced. So Negan this is Negan, she works with me. Tanya's left, and Ryan Gustafson and a whole bunch of the students from here made an AI program for us for our conference that we had last September. And I said to the kids, or the students, I know as a business owner, when I send someone to a conference, I decide how successful that conference is by how many new contacts did they make, how many new connections they made. So they come back to me and they have to tell me. But I know as humans, when you show up at a conference and you see Paul, I'm going to go right up to Paul. Hey, Paul. And then the next 2 days, we're getting drunk and we're having a good time. But I never made any new connections. So what we did is when they came in the door, we asked their permission if we could take their LinkedIn profile, because that's just the professional side of them, and put it into our AI. So they gave us their permission, we put it into our AI. And then the AI got them all made groups. And then we had a network session and everyone had to sit at a table and the AI then made up questions, talking points that they all could talk. It was so successful. Everyone's still talking about it. Royal Bank's still involved in it, right? Yeah, it's really neat. Why I'm telling you this is our youth in our community learned how to do that. Ryan is born and raised here, right? He's like third generation here. And we're creating something for these youth that can do something to create jobs here. So that's part of our goal here is this freaks me out. So I'm trying to, through the Tech Hub, do this.
So in that 97 million, how many of the jobs created are high tech?
Not that, it's a bit of a mix. Here, let me go back to that.
But it allows us to identify them and put programs in place.
So these are the jobs it will create. High tech, not high tech. AI generated work auditor, not high tech. You're just looking at things. You're just looking at words, what it's written, what is said. So there's a big mix here. Ethics, like that's, no. And also,
Your you're a young guy out there working in the oil field. I just want to say,
Yeah, yeah,
you know, those aren't high-tech jobs. We still need those people.
yep,
We need their expertise in that field.
yep.
So where do they fit in that 97?
So when we start to automate some of their processes, and I'll give you a good example of this, Egg Truth, the guys that I showed you, they have here, these guys are the guys that work at the grain elevator. They go into their office and spend a week or two there and saying, you got this right, you got this wrong, you mismold here. So those guys are going to be the trainers. But here's another thing, there will be a point where you've trained enough. So countries like Singapore, someone my age in Singapore can go back to university as if I was 19 years old and getting the same credits, getting the same money, and moving on if I want to. And I would love to see that more and more here, instead of saying, because all of us have these skills. It's just, have we taken the time to learn that, right? So if we choose to want to learn these new skills, they should be open to us. And a lot of countries are doing it. Unfortunately, we're not.
So training is an ongoing process all the time.
Yeah.
You know, it doesn't matter what level it's at, it's still there, right?
Yeah, 100%.
So where does this fit with medical? Different topic, isn't it?
So my son is here because do you mind? He's doing physio. He's learning how to be a physiotherapist, and he's just finishing off studying or practicing at the hospital here. My wife's doctor. I think what's going to happen is you're going to still need my wife and my son at the top, double checking to make sure everything's right, but they're going to have new tools to make things faster and easier for them, and make sure they make less and less mistakes. Like the DSM, the book that my wife has to study every year, is like this big. And she does her tests, they can just take one piece out and you have to know it like verbatim. And they're just simply those recipes. This symptom, this symptom, this symptom, do this test, do this test, do this test. Therefore, it's this diagnosis. Well, that's perfect for AI. So,
Yeah, so for an example, we're trying to get an MRI lifespan.
yeah, yeah.
So they say you got to have all these trained people.
Yeah.
I don't believe that, because they say when you do an MRI lifespan, somebody in Australia or somebody
Yep.
whatever, anywhere in the world can actually diagnose and you know.
Yep.
So is that all where AI is about? Is that where it's going?
Well, MRIs won't exist without AI.
They won't?
No, MRIs have to have even the basic level AIs way back in the day, right? Because remember how I showed you AI has been around since the 50s? So there's that. AI can do image recognition at this point and tell a radiologist, hey, did you see this? Did you see that? So it would speed up the radiologist on how many images he can look at and get accurate, but we won't get rid of the radiologist. I think where you're more talking about is remote work.
Yeah.
That's not really AI per se, yeah. And yeah, I think we're using Alberta or Ontario or someone to, hopefully I'm not getting myself in trouble.
That does interpretation.
Yeah, yeah. I think that's great because it's pretty hard to get doctors out here.
No, and you got a lot of other professionals looking at the same thing. If you want it, you know, I could go in and have an MRI, and 100 people could look at that MRI and all come up with a different diagnosis or whatever, right?
And then we're getting more consistent, yeah. You know, what's also interesting about the MRI is we have a quantum lab at U of S, and we also have Artificial Saskatchewan, and they're trying to get MRIs to the point that they're portable. Like, you know, the echocardiograms or whatever. Yeah, pretty soon you have an MRI where you can just go like this. Yeah, that's their goal. I don't know if they're going to get there.
But on the other hand, what I experienced, there must be a system, I don't know whether this is AI, but in Switzerland, the doctors have the computer. You tell them your symptoms, they put that in for diagnostic. And once I went, I kind of set my symptoms and put it in, and then he looked at the computer and said to me, but your symptoms, it doesn't match together. It doesn't go together. And then what? It doesn't go together. So
They're not, it's not always
That's where the
100%.
human aspect comes in, right?
But
Yeah,
it's very awkward. You go in, say, I did this, and he said, but that doesn't match together.
Well, to your point, like, so my wife's from Iran.
Yeah.
And so she learned how to be a doctor behind the boycott, right? Or not the boycott, the tariffs or whatever. So they have old 1950s, 60s equipment. So she was taught medicine with her hands and her eyes. And so she diagnoses. And her joke is, a Canadian doctor, like, you could walk in with a broken leg, but your blood work says it's not broken, so they'll just let you out the door. Right? Right? So the point is, if now we interpret that to our discussion about AI, we're still going to need a human to say, no, that guy's leg is still broken. Right? So it's just going to be a tool.
So you're always gonna have human involvement in every aspect.
100%. You're going to have to. When you're making those kind of decisions, you're going to have a human. And also with physiotherapy, you're going to have a human manipulate the things. Yeah. So.
It's like if you go to the hospital or a doctor says, okay, you have this and this and this, and you say, well, I'd like a second opinion. I'll go to another doctor, right? You get a second opinion. Same idea, right?
I do have one other question. So you talked about AI, about making the laws and making laws right now, okay? You're into this stuff. What, in your best guesstimate, how far are we away from AI to actually where it's going to break the law?
Oh, see, this is so how far away are we going to be from AGI or general AI? So if you listen to Sam Altman, who owns a not-for-profit charity, that's the whole thing. He created a charity and now he's making it a for-profit company. He just did the biggest raise in the history of the universe for venture capital. It was crazy because he said he's going to make AGI in 2 years. Right? To me, that's a bit of an Elon. I'm going to just keep on telling you that you're going to have automated cars, you're going to have robots. He's just trying to raise money. That's a bit of the hype. When I look at quantum computing, because we're not going to get AGI until we have quantum computing. So I see that's 2 or 3 years. It could be, and when I look at that, it could be 5 to 10 years from now.
So that's not very long.
No.
But just going back to the job.
So when you see Lori, get her on it now.
Going back to the job losses versus the job opportunities. We have a thing called Career Bridge, actually.
Yeah.
Active here in Estevan.
Yeah.
And basically you go in and tell them what your interests are, give them your resume, and they'll punch it in the computer, and through AI or some AI programs, it comes out and tells you, well, you could be suited for this job or this job or this job, as opposed to the job you're doing, right? So it gives you some ideas where you could excel. You might make something you're not even interested in to start with, but all of a sudden it's like, oh, and it's available here through the Tech Hub, right?
Yep, it is. It's on our website. I guess I'm also going a little far into the policies and the laws because I think it's important. I also, just like dynamite, see it has positives, right? Just like the wheel, we wouldn't have tanks, but we do have cars. So I do think it's positive in my personal opinion, and I'm open to debate. It is good that what we have, we just need to be careful with it. Kind of like when the internet first started, it was a wide world of like crazy imagery that we won't even talk about that you can do now. We finally made bullying laws and all that stuff.
Technology, we're going to watch the people making that technology.
It's always people.
Dr. Evils are up there.
We can create a program AI to detect from a law where are how can I kind of tweak the law to get through without being punished.
We are already doing that.
Sorry?
We are already doing that. If you look in the States especially, there's legislation that it's on the floors of different states that are verbatim exactly the same. Because one of the think tanks used AI, ChatGPT, to create a law, and then they pass it out. So we're already there. But there's the ethics there. What about using AI to catch people breaking AI laws? But do we want AI to be now a police officer? Do we want a human being overseeing AI to make sure that, because it would be, like with the password protection, we're going to need AI to make new passwords, so we're going to need AI is a tool for police officers, but we're still going to need people.
Oh, what a great presentation.
Yeah, thank you for coming.
Before all this, you need the power, right?
Sorry?
Before all this grows and grows, you need the power.
Yes, we need lots of power. Hopefully, this community will make some money and jobs and wealth by making some of that. I would love to see Mars with the Deep Earth. Maybe she can do a data center. The SMRs, when Jeff Sandquist came out for our conference, and because he was with Microsoft, he was saying that the head of data services or AI is a nuclear physicist. That's how much they believe in the SMRs. So
He's gone over to Walmart.
yeah.
300 megawatts doesn't get you very far.
No, but then the qubits are going to happen, and there's going to be something else other than qubits, and you know, like everything, money's going to drive. That's the biggest cost to your business in doing AI. You're going to spend a lot of money to get that cost down, and so there's going to be a lot of product development, applied research to get that cost down. Yeah.
Well, and the other thing too, I've heard about this. I think it was like Mark Rober, someone was watching, but you know,
I like
what
Mark
are the
Rober.
things 20 years ago that didn't exist today? That, you know, AI or whatever is going to help us invent that we have no idea that we're not even thinking about.
Well, there's a really good example, proteins. So how a protein, I'll get to, I won't forget, but how a protein combines with its different elements, carbon, hydrogen, oxygen, and what else, is one thing, but how does it fold? How does he get all these molecules, but they all get, all the molecules that like have little magnets in them, and how does it fold? And how it folds is how it does something. It makes a muscle move, makes your food digest, what have you. So they, in the 70s, created a prize to get someone to model how things will fold. They'll say, here's a molecule. Now your model has to guess how it will fold. The first one they ever did using classic computing was in the 90s, and it was 70% accurate. No, 50% accurate, sorry. And everyone was super, super excited. Then someone realized, if I make, you know, periodic table of all your different elements, carbon, hydrogen, oxygen, those are letters. I already have AI that can write words. So they put the two together to use a large language model and taught it the language of organic molecules and how it folds. Last year, they mapped out every single known protein in 1 year. Insane. And now they're going, I need a protein that will decompose plastic. And the computer then creates this molecule they've never heard of. They go in the lab, it meets plastic. Yeah. And they're doing that with cancer. Like, I need a molecule that will only attack this type of cancer. So there's a positive there. So, see you, James. Yeah.
To your jobs question and what we've been discussing, questions. Do you know what the most common job was in the 1880s, 1890s?
Blacksmith?
That answer.
Blacksmith?
Close.
Oh.
Farrier.
Oh, really?
Do you know what the most common job is today for males, men in North America?
Laborer?
Driver.
Getcha.
The point is this, and this is what I'm seeing from my vantage point. When we look at AI as an economic disruptor, and it will be.
It is.
It's the same as when you had the development of the engine come in, and all of the farriers who, for those who don't know, you clean hooves and whatnot on horses, they lost their jobs. The same will happen. But how do you imagine and explain to somebody living in 1890 that somebody someday could have a job as a steward on an aircraft?
Yeah.
It is, you can't, I mean, I appreciate the list that's there, but
Yeah.
the reality is,
We don't know.
it is impossible to imagine what doesn't exist yet. And because who would have believed that you could get on a 737 and go from here to Mexico, and some lovely person would come by and bring you some pretzels, hopefully, if you're on, you know,
A nice airline,
nice airline.
not WestJet.
Without delay.
God.
Right? Like you can't, that's what this is gonna do. Will it create problems? Yes, the same as what happened with the Industrial Revolution. Those same problems will be there. The question is not whether those problems will be there. The question will be, how do we adapt and use our intelligence, to go back where you began, to deal with that as a society and as a community.
I really like what you said, because to your airplane, we had to create laws for the airplane, or else they would crash into each other.
And they're still doing it. I mean, even those laws are still evolving.
Yeah, 100%. And then to your point, let's not talk about 1880s. Let's talk about 1970s, when I was a 6 or 7 year old kid, and people said, "Oh, what did you want to do when you grew up?" And I said, "I wanted to be an astronomer." That was a thing. If that person said, "You're going to stand up in front of a group of people and talk about artificial intelligence because it actually exists now, and that you're going to have a mobile computer in your hand that can take pictures and can do this and fold and do all these crazy things," like it's going so fast. And that's why a lot of people will think, because of what I do for a living and how I'm so involved in tech, I just want to bulldoze over everyone. It's like, no, I got the empathy. I understand. Like, I feel things are changing so fast. I created a software company running on these, and created one of the first apps in the world to ever track a phone GPS. Well, I didn't. One of our employees did. You think, but that doesn't count anymore. We had to evolve just to, so yeah, 100%. Sorry, I'm on a soapbox. I totally agree with you on every single level.
But it's kind of to develop an idea how it could go, right? That's what we can do right now.
Yeah.
Kind of make an estimate how it could continue. Also with this graphic that you showed about the energy consumption, it is a hypothesis, right? It's not. We don't know.
No, we don't know.
In reality.
It'll be fun to watch this video in 10 years.
Yeah.
If we can. Any other questions? So I just want to end it this way. I love doing things about, like I did one on EVs, and it was the same thing. It was, I'm not going to tell you what to think. I'm not going to try to make you to come over to the dark side. I'm just going to explain to you how they work. So same with AI. So if there's any other technology thing that you would just like, that non-emotional, this is how it works, please let us know. You can email us. We've got pieces of paper on our desk there. You can just write it and just let us know, and we'll do that for you. Sound good?